Okay, let's start. In this week, we will solve the questions related to the free vibration, which is generally related to the damped vibration, damped or undamped. Okay, so let me share my screen so that we can go to the presentation. Okay. Am I audible? Am I audible to everyone?
Yeah, you are audible.
Okay, so in this we will solve seven questions. Week two. Last time we have solved some like the questions related to the degree of freedom, and some questions related to the spring combinations parallel in the series, and then we solve some equation of motion. Now we will go through some properties of the free vibration, like finding out the natural frequency of the system and the damping of the system, like critical damping or the under damp or the over damped system. So let's go through these questions. For now, the first question is the like we have last time we have given a question like we have four options. We have to find out that the, which one is the critical damping coefficient is not like incorrect option. So can anyone tell me like which is not represent the critical damping? You can take 1 minute.
C.
C. Okay. Anyone other? Any other?
Except everything is not critical damping.
Okay. Your answer is A. One student answer is C. Okay. Anyone else?
Except everything is incorrect, I am saying.
Except A. Everyone. Everything is incorrect. Oh.
Yeah.
Okay. You are saying that B, C, and D are not representing the critical damping. Okay. Let us check. Let me check. So as we all know, like the critical damping can be represented as a 2 xi m omega n. So for critical damping, the damping ratio is 1. So C is 2m omega n. So your answer A is correct. Now we have to we have to rearrange some terms. Like as we all know, omega n square is equal to k by m. If we put the value of omega n square or omega n, then it would become C is equal to 2 under root km. So B option is also correct. Okay, now we come to another option by rearranging the another again the terms. Like in this we arrange the we can put the mass as a k by omega n square. Like we arrange this term, again, and then we are going through this, and then if we put these terms here, or like if we put these terms into this at the place of m, so like our m would become k by omega n square and omega n, so c is equal to 2k by omega n. So our three options, this one and this one, these three all correct except c. We can't represent our answer in terms of the c. So one student was there who told that except a all the answers are incorrect. Have you understood?
Yeah, I have understood. It is a representation in terms of other parameters. Thank you.
Yes, that was the in the terms of the other parameters. So here, like the option C is the incorrect options. Now we have a question related to the successive amplitude decrease, like the due to damping the amplitude is decreased. So as you know, like damping can represent in terms of like delta is equal to 2 pi n, or we call it written it like as a 2 pi n, sorry, not this, we written it as a 2 pi n over 1 minus xi square, and delta is ln divided by ui plus 1. Okay, so we have to find out like the ratio ui in this question, ui divided by ui plus 1 is equal to e raised to power these terms. Okay, or in some where we use e raised to power 2 pi n directly. Anyone knows when we use the neglect these terms, like the below term 1 square root of 1 minus xi square to simplify the equation.
When zeta is less than zero point 0.2.
Yes, if my damping is less than 20%, then we can ignore this. So we have three damping values, like 1%, and the another is the 15%, and is a 25%. So can you calculate the ratio ui divided by ui plus 1? And the options are there, like for a b c d. So can you calculate? Give a try, like the ratio of successive amplitude. Here your n value is 1 because like we haven't like, as there are number of cycle we have considered 1. Anyone is with the answer? Like first two you can calculate with also like simplifying the terms, like as the damping is less than 20%. So first for the damping 1% and the 15%, you can go with the simplified terms, like ui divided by ui plus 1 is equal to exponential e raised to power exponential 2 pi. Or if you want to calculate like the considering the whole terms, then you can also do that. There is no issue, like not much significant difference. But if the damping is greater than 20%, then you will see that how much is the difference.
Option B is correct.
Okay, from your side one student says option b. Anyone? Like first two maybe like the first two, these are the same in the three option, like two options. Like the first two I have sure that these are the answer. The last one I don't know what is the answer, so we will find out. Anyone else find the answer, calculate the answer, like which option is correct? Anyone? Let us discuss. Like a successive amplitude ratio, as we discussed, is given by the 2 pi xi. Sorry, there would be xi also, like initially I forgot that. 2 pi xi divided by the 1 minus xi square. So for the damping 1%, we calculate. So successive amplitude comes out to be 1.06. For the 15%, we calculate it is the 1 2.59. If you will calculate by simplifying the terms e raised to power 2 pi xi, then it is comes around 1.04, 1.05, and this is comes around 2.55 something. If you, so there is not much difference. And if you go with the 25%, then it will come down to be 5.06. So option a is correct. So someone maybe has calculated through simplified term. Someone has answered the b. Have you understood what you have done in the calculation mistake?
Yes, sir.
You have calculated by the simplified or the like using the whole terms?
Simplified equation I used.
Okay, so for the 20% greater than 20%,
Ah,
we have to
yes,
use
yes.
it. Okay. Is there any doubt up to these two questions? Anyone? Okay. If not, then we go to the another question. In this question, like you have to find a natural frequency of the system. Like the system is given to you. Like in the last class, we have developed the equation of motion for the some examples. Now in this, you have to like first find out the equation of motion, and then you can find out the uh, natural frequency, or directly if you know any way like find out the what is your k equivalent, what is your m equivalent, then you can also find out the natural frequency. So like first try to develop the equation of motion for this system. If I apply a x displacement to this point, let us say o point, or like assume a small rotation about the hinge, like this hinge, if I apply this way, like in the upper direction, like theta, in terms of the theta, because if you calculate the equation of motion in any terms like theta or x, the natural frequency would not change, it will same. It is the ratio of the equivalent property k equivalent divided by the m equivalent. So give a try and calculate what is the natural frequency of the system. First you make the free body diagram of the system. If you would be able to make the free body diagram of the system, then you can calculate easily the natural frequency or the equation of motion of the system. Can anyone tell me what is the mass inertia of this bar about this hinge? Anyone? Like last time I have shown you some calculation, like how we calculate the mass inertia of any bar. Like we have also calculated about some end, about the end of the bar or at some another point. So if you are able to calculate the mass inertia of the bar about the hinge, can anyone give me the answer what you have got? This is the simplest like question, like in which you have to take the moment, and like some it is like around one or two line question. Like anyone is come up with the equation of motion?
7 by 48 ml square.
Okay, that is your the mass inertia. If you are able to find out the mass inertia, then it is nothing like the take amount moment about the hinge, and you would be able to calculate the natural frequency of the system. Okay, let's we discuss like the small rotation about the hinge as I have shown through this diagram or this way, the theta rotation. So if there is a rotation theta, there is a reaction force Ft, damping force from here, Fs, spring force, and there is a rotation like the I theta double dot. So for this like displacement at point A, you can calculate theta. Like if you do theta displacement rotation, then this is theta into L by 4. That is the displacement in the spring, and the displacement in the damper is theta into 3 L by 4. Okay. Now you have to take the moment. What is the moment like about the hinge? I theta double dot plus FD into 3L by 4 plus Fs into L by 4 is equal to 0. Like all the moments are in the counterclockwise direction. Okay, so if we take moment about this, first like we have calculated the mass inertia of the bar, and the moment about O is this, as we have discussed. I theta double dot Fs into L by 4 Ft into 3L by 4, and the mass value is the 7 by 48, this one. Now with this help of this equation, can you calculate the what is the natural frequency? Or let me rearrange the equation so that would be helpful to you. Like what is my spring force? Spring force will be the k into displacement in the spring, which is xa, and which we have calculated theta into L by 4, and ft c into theta dot into 3L by 4. So if you put these equations, this into this here ft into this, then you will get the equation. Now from this equation, can you tell me what is the natural frequency of the system? Anyone? That would be in terms of the k and m also. Like there is a no particular value has given to you k and m. So please tell me what is the your natural frequency.
4 by 7m.
4 by 7. That would also the k by n. Let us look at like what we have got. Like I have divided this equation m terms in this in the both the side. So like this terms represent by the omega n square. Okay, so that is the 3 by 7 into k by m. So it will be the square root of 3 by k, 3k by 7m.
Okay, okay.
So anyone has any doubt in this question at any point in this question or the in the previous questions?
So in this type of question, we have to make the equation in this format, and the coefficient of stiffness will be omega square.
Yes, yes.
Okay.
Like there are another methods also, like related to finding the through the energy methods, like potential energy or the kinematic energy. Through that you can also find, but that is not covered in this course. So we are in this course is attached to this equation. Like first we have to develop the equation of motion, and then we have to find out the like the what is the parameter.
Okay.
Anyone? Okay, let us move to the another question. In this, for a free vibration test of a single degree of freedom system, mass of the system is given as a 20 kg, and it is displaced by the 2.5 centimeter by a hydraulic jail, and then suddenly release. At the end of the 20 complete cycle, the time is 3 seconds and the amplitude is a zero point 0.5 zero point 0.5 centimeter. So we have to determine the stiffness of the system, and we have to determine the damping coefficient of the system. So you have given the mass 20 kg, and like the displacement is given by the 2 point like the is displaced by 2.5 by the hydraulic jack, and then suddenly release, and at the 20 complete cycle the time is 3 seconds. Like you have given the like the what is the like the initial amplitude is the 2.5 second, and after the 20 amplitude of the cycle 20 cycles the amplitude is the zero point 0.5 second, and the total time is the 3 second. So first you have to calculate the stiffness of the system. So can anyone tell me like the stiffness, how we can determine the stiffness? Like if you have a simple system, like the you have the period of the system and the mass of the system, can you calculate the stiffness? Like if you have any system, nor any system, like, and if you have the stiffness, like if you have the mass at the period of the system, then you can you find the stiffness?
Yes.
Obviously you can find, like as you know, t, like the time period t is equal to 2 pi square root of m by k. So here m is there, and t you have to find what is the t. So this is not the damped system. Wait. Okay, so you have given the, for the part 1, like the number of cycles are 20. So for the total time period in the, like the one cycle time period, you can find out, like the total time of the 20 cycles is the 3 second. So for the one cycle time period is the 0.15 second. So with the use of 0.15 second, can you find the stiffness of the system? Anyone with the answer? Like you have given the time period.
Can I just try?
Yeah, you can try. Like I have given time for you to like calculate the stiffness.
35091 Newton per meter.
3509192.
92.
Okay. Anyone has calculated? Okay. We look at the answer. Like as Tn is equal to 2 pi square root m by k. So Tn is 0.15 second, 2 pi square root. So that is the k is equal to 35091. Like that is the same answer like as you have got. Okay. So this is our stiffness of the system. Now you can determine, find out the damping coefficient of the system. Like for the damping coefficient, first you have to calculate what is your damping ratio, and you have to do the same thing which we have done in the over in the second question, like calculating the damping ratio. Like can you calculate, like are you able to calculate the damping coefficient, like how you can calculate the damping ratio? Because damping, you know, damping is like 2 xi m omega. We have different terms, like we have m, we have omega, and we have, like we have to calculate only the damping ratio. And the damping ratio you can calculate by the, like, by the logarithmic decrement. Ln is equal to ui divided by ui plus 1 is equal to 2 pi xi n. So you have ui as a, how much ui, that is the 2.5 centimeter, and ui plus 1, what is ui plus 1, it is the zero point 0.5 second, zero point 0.5 centimeter, and you have 20, and then you can go with the damping. Anyone with the answer?
Sir, I have a doubt.
Yes.
Sir, this is actually an undamped system, right?
No, that is a damped system, no? If that was the undamped system, then how you can say like the, like that displacement for the undamped system, the response like the same, it will not decrease. For the damped system, that is decrease, like this one. Have you understood?
But we found the time period assuming it is undamped system, right?
Okay, now like the time period, like if this is your cycle, like there are 20 cycle, okay, but the time period of this will be same. Like if that it decrease, so cycle, the time period would be the same, time period will not decrease.
Okay, okay. Even
On,
if there is damping or
yes,
not,
yes,
that.
only. Like you can go with the TD damping, like finding out the TD, but that is like very small,
Okay.
so that is not much effective here. So for the successive amplitude ratio, as we defined, logarithmic decrement ui divided by the ui plus 1, 2 pi xi n. So that is the 2.5.5 to 2 pi xi 20. So the damping ratio is 1.2%. So like this is like the part 1 and part 2 are not related. You can also calculate the part 2 first, and if you want to calculate the TD is equal to Tn 1 minus I square, so that would be same because the damping ratio is very less. Okay, so that doesn't affect. So the damping coefficient is given by the, this is 21.44 Newton second per meter. Have you calculated, anyone calculated the damping coefficient? Is there any doubt in this question? Anyone? Is there any doubt in the question? Anyone? Can you hear me?
Yes, sir, it is clear.
Okay. Now we have come in a question which will a, like a diver weighing a 1.5 kilonewton is standing at the end of the diver board. Considering the diver board is a massless, the board acts as a cantilever beam of the length 1 meter. If the combined system is oscillating at the frequency of the 3 hertz, what is the frequency flexural stiffness of the diver board? No, you know what is the diving board? Like if you have seen in the swimming pool, like there is a board here. So from this app, like anyone can stand here, and then after like jumping from here, then it start into jumping into the swimming pools. So this is the diver board, and there is a diving weight, like the standing at the, like any person is standing whose weighting is the 1.5 kilonewton. So you have like the length of the diver or the cantilever is given as a 1 meter, okay, and the frequency of the system is given as a 3 hertz. From here you can calculate the time period. If you can calculate the time period, then you can calculate the stiffness of the system. And if you can calculate the stiffness of the system, then you can calculate the EI of the system. Anyone has any doubt? Like you can give a try. Like if the frequency is 3 hertz, can you calculate the what is the time period of the frequency is the 3 hertz? Can you tell me what is the time period? Time period is 2 pi f, and f is your 3 hertz. So your time period is this. Okay, this is calculated by the time period of the 1 by hertz, 1 by f. Okay, sorry, that is time period is calculated by the hertz in this. Like that was the 2 pi n is the another thing that I was considering initially. So you have given the mass, like the weight is given as a 1.5 kilonewton. So you can calculate the mass of the system or the mass of the lever divided by the 9.81, and the stiffness of the lever board, you know, K is equal to 3I by L cube as the stiffness of the cantilever.
Cantilever.
So L is here the 1 meter, so that is the 3I. And if you have the time period is the 0.33 second, so can you calculate the stiffness through the time period? Value the K dash or some K. Like you have the mass, you have the time period, then find out the stiffness through the period. Give a try. Anyone give a try? For the time period, like sometime you know that the omega is equal to, what is omega is equal to 2 pi f, and omega can be written as 2 pi by Tn, and that is the 2 pi into f. So if 2 pi will be cancelled out, so this relation is the 1 by Tn is equal to f, or f is equal to, like the, or the t is equal to 1 by f. This way we have calculated the time period. Anyone find out the stiffness K value through the time period? Anyone?
54326.
Okay, let us check what is the stiffness. Tn is equal to 2 pi square root m by k. So that is the 54328.026. That is correct. Now with the help of this, you can find out the EI value. Like equate this with this. Find out the EI value. Like divide it by the 3. That is
3.
your directly EI value. So your EI value of the lever is the 18109.36. So anyone has any question in this question? Any doubt? Okay, if not, then we are moving to the another question. Like this is the packaging related question. Like if you have seen, like in we have ordered some parcel, we ordered something from the Amazon or the Flipkart or any other, like we are getting into the packaging, so there is some foam or the, you can say that thermocol in this, inside this, that work for the stiffness or the damper, so to protect, to take the impact of this, of the outside, if that product is dropped from some height. So from that point of view, we have to calculate like the two part. Like the question is, the packaging of the instrument can be modeled as shown in the figure, in which the instrument's mass is restrained by the spring of the total stiffness K inside the container. Mass of the product is the 4.5 kg, and the stiffness K is the 9,000 Newton per meter. The container is accidentally dropped from a height of the 1 meter, assuming that it doesn't bounce on the contact. So first determine the maximum deformation of the packaging within the box, and determine the maximum acceleration of the instrument. So this is the simple, like the free vibration case. You have the stiffness, you have the mass. Only the question thing is changed is the initial conditions. So can you tell me what would be the initial condition? Like there is an impact type case also. Like let me show you the what is the initial conditions for this.
So
Initial
root 2gh.
initial displacement would be the mg by k. Mg is the weight of the product, and the k is the stiffness. So that is the initial displacement. And as you told me that the initial velocity would be the 2gh, square root of 2gh. So the x0, like the initial displacement and the initial velocity you have given. So now you can find out the what is the maximum deformation. Like the what is the response or the like the what is the response of the free vibration. Xt is equal to a cos omega t plus b sin omega t. So from this you can calculate the maximum deformation in the packaging. So first calculate what is the value of A and what is the value of B from the initial conditions. Is there any doubt in the related to the initial displacement in the velocity? Anyone?
It's clear, sir.
Okay, so like find out the what is the over your value of the A and B. If you would be able to find the A and B, then your maximum deformation is simple. Like if our equation in these terms, so your maximum deformation will be the square root of A square plus B square. So you need to find out the A and B.
A would be x naught itself.
A would be the x naught itself, okay. And what is the B?
X dot of 0 by omega n it is.
Yes. So like in the in the if you have seen the NPTEL like the during your video lectures, like there is a like we have written the equation in terms of the xt and x naught is the x naught cos omega t plus x dot naught divided by the omega n sin omega t.
Sin omega t.
So this is your maximum deformation. With the natural frequency you can calculate to find out the maximum deformation, which is like this is our equation which we have written. This is the same equation. Now can you find out what is your maximum deformation from here? Have you find out?
90 centi.
Let's check. Okay, that is the 9.9 centimeter.
Okay.
Now the next part is the you have to calculate the maximum acceleration. So if you have given the maximum deformation, so maximum acceleration you can directly calculate it as a, have you know you do you know how to calculate the maximum acceleration? Like if you have given the, like the maximum deformation, you have to find out the maximum velocity or maximum acceleration. You have to simply, like for the, if you have to find out the velocity, you have to do this is a multiply with the omega n into x max. And for the maximum acceleration, you have to do it at omega n square into x max. So you have the omega n square, omega n value, and the maximum deformation. What is your acceleration? Like that thing, sometime if that was the damped system.
Sir, this equation is derived from our equation of motion itself.
Which one?
This equation for maximum acceleration.
No, no, like these are the, like the basics. Like if you have gone through the week zero assignment, I have discussed these. Or these are not from the, like the equation of motion. These are the relation of the maximum deformation. Like if you have read in the uh, your
Engineering mechanics.
engineering mechanics, or in your, even in your 12th standard or 11th standard,
Okay, okay.
like you have read, like these relationships are given there. Or in the next
Okay, sir.
class I will like told you like how they are comes.
Okay.
So the, if you have the omega n, what is the omega n? In the previous question we have given the omega n is the, like in this question, 44.72. Okay, so if you will multiply this, then you will get your maximum acceleration. Is there any doubt up to this point in the whole last six questions?
It is clear, sir.
Okay, so now let's move to the last question of this session. Like you have given a structure initially at the rest, and it gives a initial displacement and left to vibrate. And after how much time it would be, amplitude of the vibration would be equal to the half of the initial displacement. Okay, like mean, I have a system like this cantilever. I displace it at some point, initial displacement, that is the u naught, and I left. So at what time my ut would be u naught divided by 2. So we have to find out the t. Okay, so the properties of the system is given as a, stiffness of the system is given as a 20 kilonewton per meter, mass of the system is given as a 5000 kg, and the damping is the 1. So if the damping is the 1, then what is the case? Can you tell me?
Critically damped.
So do you know what is the like the solution for the critically damped system? Like mainly we are focused in the, like the, in the case of the under damped system. And do you know any example related to the over damped system where we use the over damped system?
Door closure.
Yes, door closures we require the over damped system where we want the response to decrease like slowly, and like there is not any like the oscillations type. So for this, for the critically damped system, my, like the, have you like the, for the critical damped system, if my, the equation in which the root equation, that is the zero, like only the my roots are lambda 1 and lambda 2 are c by 2m, and whatever in the roots are, things are 0. So this term would become 0. Like I don't know what is in the inside the root. So two roots are equal. So can you tell me what is the solution of the differential equation if two roots are equal? Like during the solutions of the like the all three type of the system, like the for the critical dam system, you have got these terms c by 2m plus minus and something root. So if the root this one is less than 1, so you call it as a critically damped system. If this system is greater than 1, you call it as a overdamped system, and this system it is equal to 0, you call it as a critically damped system. So if you have a two root, like the root is a like the lambda 1 and lambda 2 is the c by 2m. So what is the equation, what is the solution? Like if you have two root like lambda 1 and lambda 2 are real and distinct, so your solution would be the a into e raised to power lambda 1t plus b into e raised to power lambda 2t. Now these two roots are simple. If the two roots are simple, the solution would be the a plus b t into e raised to power lambda t. Okay, understood? Do you have any doubt?
It will be a plus b t.
Yes, because the lambda like the this function in terms of the t now, like that is the by t. Or if you have solved during your like the mathematics, that is terms of the in the x, like some differential equation you were like due to y over dx square and something something, and your roots are m1 and m2 are equal to m. So your solution what was the a plus bx into e raised to power m1x mx. That was the
Okay,
solution.
okay,
Have you remember it?
okay, okay, okay,
So that is a t because our equation in terms of the t.
okay, sir.
So lambda 1 and lambda 2 is here, c by 2m minus c by 2m. And if you solve it like c, what is the value of the for the critical damping value? C value is the 2 xi m omega n, and xi value is the 1. For the critically damped it is 1, and that will cancel out this. So my two roots are equal, and that is the omega n minus omega n. So for this, if I calculate the response ut that I have discussed here, y is equal to a plus bt into e raised to power lambda t. So ut is this. Now you have to apply the initial conditions. Like here the initial condition is that like we have the given the initial displacement and there is a nothing regarding the velocity. So you take the initial conditions are u0 and u dot 0 is equal to 0 because only the displacement is given here. Okay, so in this terms, like by applying these two u0 and u dot 0 is equal to 0, can you find out what are the coefficients of the a and b? Give a try. There are very less student actually in this course, I don't know why. Are you able to solve the assignment 1 of the week 1?
Uh, Two questions I was having doubts, sir. Actually.
Okay, that was maybe I think one is related to the degree of freedom, the pulley one, and some related to the equation of motion.
No, the related to the equation of motion, there was two rods coming, and both of them were rotating about different points. So how to make the equation?
Like if you like the rotation regarding in the lecture, the sir also has discussed a lot of about the pulley system or the some.
It is not the pulley system.
It is some the vehicle.
It is actually Question number question number 7 of assignment 1, sir.
Is there any like the vehicle, like the police system, something else? Like
No,
I
there are one mass which is that is a rod which is hinged at one point, and through a rigid link it is connected to another rod which is having the same mass.
Oh, that is that kind of question. Like there is a something and something road here, some road here there, and that is connected to the origin link something.
Yeah. So
So
how
you
to
can
make
take
the
it like the break it like this. Like you can take like if you rotate it like this, then it will also rotate like this, and then you can consider like the force. Like this link can transfer the forces or the displacement. So you can take it like if this is rotating like this, then there is a resisting force this F1 here, and like you can take any direction. This is and F2 here, F here, like the same force transfer by this link. You can break it actually. You have to through the link, and then you would be able to solve it.
so we have to add both that.
No, now after like if you find out the equation of motion this in terms of the F, like there is a terms of F, okay, and then you solve
Okay.
this, there is also the terms of the F. From any one of you can substitute into this, so F will be the neglected.
Okay.
Understood?
So we have to find that f first.
Yes, you can find out like the F first in terms of the like that is your depend. Like you can find out the equation of motion some equation like mx dot and cu dot is equal to F into something, and here also something into like same equation, and then F dot into multiply this and then substitute the F will cancel out. There is nothing about it.
Okay. Okay.
So you will be able to solve it. Like the link is you can see like the link, what is the work of the link that can transfer the displacement as well as so you can displacement or the forces, so you can directly can calculate this through this. Okay, so can you find out the what is your u0 and u dot 0 like with the a and b using these two?
U0 is a itself.
Okay, and what is the b?
U dot 0 is a plus b.
No,
I'm
u
not sure.
dot g like b. You have to find out the b, and that would be something. I think b is equal to uh, u0 into omega n, and that will come out to be a into omega n simply. Let us check. So initial conditions are u0 and u dot 0 is equal to 0. So for u is equal to 0. So u0 is equal to a, as you have told me. Now if you find out the u dot t, first differentiate it, and then if you 0, then you will find out the b is equal to a omega n or omega n into u0. Is it
Okay.
okay?
Okay. Okay.
Okay, now then put it into the equation, this equation, value of a and b into this, and then you will find out the like the a is equal to u0 and b is equal to u0 omega n, and if you give the value ut is equal to u0, that's u0 omega n t, into e raised to power minus omega nt. Take out the u0. Okay, now our case is the, like, at what time ut is equal to u0 divided by 2. So let us consider ut is equal to u naught by 2, u0 by 2, or u naught by 2. So that becomes the u naught by 2 equal to u0 1 plus omega nt. So u naught is cancel out, this one, this one. So this is the equation. Can you find out what is the value of t from here?
Sir, we don't know omega n, right?
You have omega n na? Like, you have given the k value and the m value.
Okay.
Have you noted that, or I have to show this?
I haven't noted, sir.
Okay, so if you haven't noted, like, k is 20 kilonewton per meter and the m is the 5000 kilogram. Have you noted?
Yes, sir.
Calculate the what is the value of t. Have you calculate? Like, simple, you have to take it like, in the calculator you can put the value of the omega in terms of the omega n, and then you have to solve a kind of equation. Anyone has any doubt in the last questions, last other questions, remaining question? Like, these are the questions related to the free vibration, like the damped or the undamped. Next week we will discuss related to the force vibration. So if you have, anyone has any doubt, you can ask here. Are you able to find out what is the value of the t?
Sir, can you show how that is solved?
You can, like, directly, what is your omega n?
2.
Omega n is 2. So in the calculator you can put, like, the equation. You know how to solve the equation in the calculator?
Hmm. Yes, sir.
Like, directly you have to put the value, like, like, this is your equation, and then if you, like, to put, like, some values, like, the numerically you can solve it, like, using some values, or in the calculator, like, if you put the value of the, like, simple 1 plus to alpha, like you can use the variable in the calculator also. Do you know how to use the variables in the calculator?
I'll check, sir.
Okay, if you will do, then the time period is comes out to be 0.83 second. You can put into this equation 1 plus 2 into 0.83, and it multiply with the minus ka 2 into 0.83, that will becomes around zero point 0.5. So you can directly solve this equation, like some equation, if you will get some time equation x sine omega t is equal to something, then directly you have to put the equation, like the variables there, the some use of the variables x y you can use in the, like the solving the equation. And you
Okay,
can
sir.
solve this equation by the shift plus solve equation, or by the variables you can put through alpha plus some variables. So you can solve these questions through this. Anyone has any doubt? Anyone, like related to this, or in the last question, last assignment, like the week one content? Anyone? Uday Shankar, you joined late, very late. Can you hear me? Uday,
Yes, sir. Yes, sir. Yes, sir.
you joined
Due to
very.
some internet problem, sir.
Okay, so if you have any doubt, you can ask me in the next session, or like this video would be uploaded on the YouTube also, so you can go through this also.
Okay, sir. Okay. Thank you.
And you can also ask the questions through the discussion form. Anyone has any doubt in the, you can ask through the discussion form. If I will give the answer to the discussion forum, or I else I will discuss here if anyone has any doubts. Okay, so I am concluding that session. Thank you everyone.
Thank you, sir.
Okay, thank you.